So, you're starting your journey with C programming. Awesome. Think of yourself as a builder, about to create something really cool. But before you can build anything, you need your tools. And in C, your very first toolbox is filled with something called data types. So come on, let's open this thing up and see what's inside. Okay, first, let's ask a really basic question. When you give a computer a piece of information, how does it have any idea what it's looking at? How does it tell the difference between the letter A for a grade, the number 20 for an age, and 3.141594? Well, you know what that's for. To us, it's all just data, but for a computer, it needs some clear labels. And that right there is exactly what a data type is. It's basically a special label you stick on your data to tell the computer, hey, this thing is a whole number, or treat this one as a single letter. It's how we tell a variable what kind of information it's going to hold, which makes sure the computer uses it the right way. So, in this explainer, we're going to unpack this whole toolbox. We'll kick things off with why these types are so important in C. Then we'll check out the tools for whole numbers and characters, jump over to numbers with decimals, explore the kind of weird but useful void type, and finally, we'll learn how to check the size of our tools. So why all the fuss? Why do we have to be so specific? Well, it's because C has some pretty clear rules of the road. It does not like guessing games. You've got to tell it exactly what you're working with right from the get-go. And this brings us to a really core idea in C. It is statically typed. What that means is, when you create a variable, you have to declare its type. And once you do, that's it. It's locked in. A variable for a number can't just decide to become a letter later on. Now, you might think that's super strict, but it's actually there to help us. It catches mistakes early and makes our code way more reliable. All right, let's get our hands dirty and grab our first set of tools. These are the absolute basics, the building blocks you're going to use all the time, the types for handling whole numbers and single characters. First up, we've got the integer, or int. This is your workhorse. It's what you use for any whole number. Counting things, someone's age, a score in a game. You use the keyword int. It usually takes up 4 bytes in memory. And when you want to print it, you use %d. That %d is called a format specifier. Just think of it as a little placeholder that tells the print function, hey, an integer is going to go right here. And here it is in action. Super simple. We're declaring an integer variable, we're calling it var, and we're giving it the value 22. Then that printf function displays it. See how that %d is just a stand-in for whatever value var is holding? And no surprise here, the output is var equals 22. The computer saw int, knew it was a whole number, saw that %d placeholder, and swapped in the value. Simple, right? Okay, next tool, the character, or char. This one's for storing just a single letter, a single symbol, or even a number you want to treat like text. It's super lightweight, using only 1 byte of memory, and its special printing placeholder is %c. So how do we use it? Well, check out this code. We make a char variable called ch and give it the value a. Now the most important detail here, the single quotes. That's the signal to see that this is a character. Then of course we print it using our %c placeholder. And boom, the output is ch equals a. It's another perfect, clean example of how the data type and its format specifier team up to get the job done right. Okay, whole numbers and letters are great, but what about everything in between? For stuff like prices, measurements, scientific formulas, we're going to need a lot more precision. So let's look at the tools for numbers with decimal points. The first tool we have for this is the float. It's designed specifically for what we call floating point numbers, which is just a fancy way of saying decimal numbers. The key word is float. It takes up 4 bytes, and you print it using the %f specifier. This is your standard go-to choice for most decimal math. But what if you need to be really precise, like super-duper accurate? That's when you bring in the double. It also stores decimal numbers, but it uses double the memory, 8 bytes, which means it can handle way more digits after the decimal point. Its format specifier is %lf. You can remember it as long float. And you can see the trade-off right here on this chart. Float is smaller, it uses less memory. Double is bigger, but gives you much higher precision. The one you choose really depends on what you're doing. Are you tracking the price of a coffee, where a float is probably fine? Or are you calculating a rocket's trajectory to Mars, where you absolutely need the precision of a double? So we have tools for numbers and tools for characters, but what if What if a part of your program doesn't need to handle any data at all? It sounds kind of weird, right? But C has a special tool for representing, well, nothing. And believe it or not, it's incredibly useful. And that tool is void. It literally means no value. Its main job is to let the compiler know that a function isn't going to give back any information when it's done. It just does its task and that's it. It has other advanced uses, but for now, just think of it as a function's way of saying, hey, I get the job done, but I'm not handing anything back to you. Here's a perfect example. We've got a function here called greet. We've labeled its return type as void because its one and only job is to print a message. It doesn't need to calculate a number or return a value, so we're explicit about that. We say this function returns void. Now, we've talked about how an int is typically 4 bytes and a char is 1 byte. But here's a little secret. There's a catch. We need a totally reliable way to measure our tools because their exact size isn't always set in stone. And here's why. The actual size of a data type can change depending on the computer you're running the code on. An int might be 4 bytes on your laptop, but on some older system or a specialized piece of hardware, it might be different. And that could cause huge problems if your code just assumes a specific size. Thankfully, C gives us a measuring tape, the size of operator. Now, this isn't a function, it's an operator built right into the language, and it takes away all the guesswork. This is so important. If you're writing code for, say, a tiny sensor, where every single byte of memory matters, you have to know exactly how much space your variables are taking up. This is how you write solid, portable code. So, if you were to use size of on a pretty standard modern computer, this is what it would tell you. An int is 4 bytes, char is 1, float is 4, and double is 8. Honestly, using size of is just a good habit to get into. It ensures your code is robust and works the way you expect it to, no matter where it runs. And there you have it. Those are the essential tools in your C programming toolbox. You've got what you need to handle whole numbers, characters, and decimals. And you get why it's so important to tell the computer exactly what kind of data you're using. You're ready. Your toolbox is packed. So, the only question left is, what are you going to build first?